Hey guys, so we're going to talk about slant asymptotes. It's just another asymptote for our graph that we need to take a look at for the characteristics of rational equations. So to identify a slant asymptote, the degree of the numerator is going to be bigger than the degree of the denominator, which means you have no horizontal asymptote. Okay, so if you have a horizontal asymptote, you don't have a slant, and vice versa. So that's a helpful little trick for you. So you're still going to do all your stuff for graphing rational equations. You're going to factor, find your intercepts. You can identify your domain. The main new thing is that you have something else you have to identify, which is the slant. So first part for this function, we're going to go ahead and factor. So r of x, you have x minus 3 in the bottom. Okay, so your binomials on the top, so x and x, 5 and 1, so minus 5 plus 1 will give you that -4. So for our x-intercepts, x is going to equal 5 and -1. Y-intercept, make everything 0. So you have -5 times a +1 up top over a -3. So now you should have 0, 5/3 as your y-intercept. Okay. Our degree in the top, right here, our leading coefficients, our degrees, we have 2 and a 1, which means we will have no HA because the degree is bigger in the top, which means we will have this slant asymptote that we're going to talk about. So keep going down your list. VA, you have a VA, a vertical asymptote at y or x equals 3. This is the only thing that's left. We're not going to do number 6, but what we do need to add is, do we have any holes? Okay, and here we don't have any holes. Okay, and we'll still do domain when we need to. So the main thing I want to talk about is how to find this slant asymptote over here. So to do the slant asymptote, you're going to do some sort of division, whether it's long or synthetic. And synthetic division, if you remember, we can only do if we have a binomial on the bottom. So it has to be this linear equation in the bottom. You can't do synthetic if you have anything else. So if it's a squared or a cube in the bottom, you have to do long. So here we're going to do synthetic. So we have 3. So x minus 3 equals 0, x equals 3. And that's where the 3 comes from. 1, -4, -5. You're going to do your synthetic division. Okay, regardless of whether you get a remainder or not, that's not what we're looking at. What we're looking at for our slant is what this highlighted portion is. We should get some sort of linear equation that we can pull from the information. So this is x minus 1, so y equals x minus 1, which means we have a slant asymptote that follows that line. So y-intercept of -1, slope of 1, so we can put in our slope going up 1 over 1, up 1 over 1, and I'm going to put this invisible line down the middle. Okay, and these functions do cross sometimes as well, so you just have to be mindful of what you have. We're going to put our other information that we have for our graph in here as well. So we have a vertical asymptote at x equals 3, so we're going to put our dotted line down there. We have zeros, x-intercepts at a +5 and -1. Okay. And we have a y-intercept at a +5 over 3, which is really close to 2, so we'll just put it right there. I just made it big so you could see it. So the points are going to help me graph. So I know on this graph, I'm going to get as close to my line as I can, connect my points, and follow the asymptote. Same thing here, get close to your line, go through the x, and go through on your way up. So this is one I could expect you to do without a calculator, because you could use the points in the asymptotes to kind of help you graph this function. Okay, so for example 2, we're going to keep going. Okay, for example 2, for the rational function given, find all the key features and graph, including your slant asymptote. So first things first, we're going to factor if we can, and here we can't factor, it's just x squared over x minus 2. X and y intercepts, so when I solve for the top, my x-intercept is going to be at x equals 0. And for y, if I set all the x's equal to 0, the top is 0, so you just get 0, 0. Here, for horizontal asymptote and vertical asymptote, horizontal numerator is bigger, so there is no horizontal asymptote because we do have a slant. Okay, and we do have a slant. We have a vertical at x equals 2 because that's what's not canceled in the bottom right there. Okay, and then to find our slant, we're going to take the x minus 2, get it by itself, so you have x equals 2. So 2, we can do synthetic division because we have the x squared with a coefficient of 1, no term for the x and no term for the constants. We have our placeholders. So bring down 1, multiply by 2, bring down the 2, 2 times 2 is 4. So really what we have here is x plus 2 plus 4 over x minus 2, but all we care about is this first part, the y equals x plus 2, because that is the equation for our slant. Okay, so we're going to put in our slant. I'm not going to do end behavior. We're going to put in our slant, which is y equals x plus 2, so start at 2, slope of 1, okay, slope of 1, do your invisible dotted line for your asymptote. We have another asymptote at x equals 2, okay, and then we have our x and y intercept is at the origin right here, okay, so that tells me part of my graph is going to be in this region right here, which means the other part of my graph should be the opposite. It should be up here. Okay, we can use our calculators to verify that, but it should follow that pattern where it's some sort of opposite. So when I draw my line, it's going to go through and then approach the other two lines. And then up here, again, you can get as close as you can and graph it. If you plug this function in your calculator, it should look just like that. Okay, so use the points you have, use your asymptotes to help you figure out where your function is going. Okay, so for example 3, okay, I want you to do this one on your own. Okay, I want you to factor, find your intercepts, find your HA and VA, determine if you have a slant and find it, okay? And then I want you to go ahead and try to graph it on your own. Okay, so go ahead and do that now. All right, so for example 3, this is what you should have. It factors to the x and then x plus 2 all over x minus 1. You should have x-intercepts of 0, -2, and a y-intercept of 0, 0. You have no HA, which means you have a slant, and you have vertical asymptote of x equals 1. Slant, your line is y equals x plus 3. And then when you graph, the zeros should help you figure out that this part of the function goes in this section right here, just because those are where the zeros are. And then the other part should be the opposite of that. Okay, so it's almost like a vertical angles reflection kind of thing from geometry. Okay, so check your work, pause the video if you need to. So example 4, same idea. I want you to do all those pieces and parts. So you're going to factor, you're going to do your intercepts, you're going to do your HA and VA, and if you have a slant, you're going to graph that, and then you're going to graph on your own. Okay, so go ahead and do that now. All right, so here's example 4. It factors to +4 + 1 all over -3. Intercepts are -4, -1. Y-intercept 0, -4/3. No horizontal asymptote, which means you have a slant. Vertical asymptote at x = 3. And then you do the synthetic division for your bottom, not the bottom, but for the slant asymptote using the bottom, x - 3. You end up with the line y = x + 8. Plot your points, put in your asymptotes. The first part of your graph fits in right here. So just because the asymptotes don't meet until this section up here doesn't mean your graph goes all the way up there. So this part, it's not graphed very well by me, but it does go into this section. And then if you did it in your calculator to check it, if you zoom out, you would see this little section up here, this little pink section. So make sure, even if it doesn't fit on the graph, that you're including that extra piece of the function, because that's the rest of it. So let me know if you have any questions. We're going to stop the video there. Have a good day.